Okay, trig equations. All of these will always say, give you a range, and I will always give you from 0 to 2 pi. Notice it includes the 0, but not the 2 pi. So anything in between 0 and 2 pi, I want all the answers for theta. So when I see cosine theta equals negative radical 2 over 2, I need to think about where's the cosine negative, first of all. So cosine's negative in those two quadrants. What's the reference angle that has a cosine, an x value, of radical 2 over 2? Well, that's at pi over 4. So if the reference angle is pi over 4, what are those two angles? We would have 3 pi over 4. And then this one would be pi plus pi over 4, so that would be 5 pi over 4. That's it. That's all there is to that one. 2. Tangent of theta over 2. So I'm asking myself, what angle has a tangent of radical 3? So first of all, I know it's going to be positive here and here. Because here it's a positive x, positive y. Here it's a negative x, negative y. So that's the two places where tangent is positive. If you don't know what angle has a tangent of radical 3, two ways you can look at it. One is you can draw the picture. That's over 1, so that's y over x. So y would be radical 3, x would be 1. So I take 1 squared plus radical 3 squared. That would be 3 plus 1 is 4. Square root of 4 is 2. And the only reason you do that is that if you've drawn theta in the first quadrant, you could also draw it in the third quadrant. But if you draw it with a tangent of radical 3 over 1, now I see that the cosine is 1/2. The sine is radical 3 over 2. And so now I said, okay, what angle is it where the cosine is 1/2 and the sine is radical 3 over 2? That would be a reference angle of pi over 3. So remember what's in here, this angle, theta over 2, is equal to pi over 3, or in this quadrant, if my reference angle is pi over 3, that would be 4 pi over 3. Now, because this is divided by 2, and it tells us that we're going to take our theta divided by 2, is that really what that is? We're going to take our theta divided by 2, and to solve for theta, we're going to double it. I don't have to worry about putting the plus 2 pi k. So to solve for theta, I just need to multiply both sides by 2. So I'm going to get theta equals 2 pi over 3. That's in my range of answers. This one, if I multiply by 2, I get theta equals 8 pi over 3. But 8 pi over 3 is too big, because that's more than 2 pi. So I have to cross that one off. So the only one I have is 2 pi over 3. Alright, number 3. Secant of this angle is equal to -2. So what I would look at is think of this as then the cosine of that angle. If the secant is -2, the cosine of that angle is -1/2. Alright, so where's the cosine -1/2? That's negative over here. And if you have a cosine of -1/2 and a y value then of radical 3 over 2, my reference angle is pi over 3. So this one over here would be, so 3 theta over 2. This one would equal 2 pi over 3. Now this one has a coefficient in front of it, so I should put plus 2 pi k. And then that same angle, 3 pi over 2, would equal down here, the reference angle would be 4 pi over 3 plus 2 pi k. So anytime there's a coefficient in front of there, we need to put our angle plus any rotation, any multiples around the circle. Alright, how are you going to solve these? Well, a couple things you could do. You can either do it in 2 steps. Multiply everything by 2 to get rid of this 2, and then divide everything by 3. Or you just multiply by 2/3. So that it's the same thing, but you're doing it in one step. So here everything cancels. I'm left with theta. This one, nothing cancels. I'm left with 4 pi over 9. I'm just multiplying 2 times 2 pi, 3 times 3. So I get 4 pi over 9 plus, here nothing cancels. Remember, this is all over 1. So I get 4 pi k over 3. Alright, so let's figure out our answers to that one. When k is 0, I'll put that up here, theta. When k is 0, this goes away, I'm just left with 4 pi over 9. If I put in k is 1, that means I'm going to have 4 pi over 9 plus 4 pi over 3, because k is 1. Well, 4 pi over 3 is how many ninths? It would be 12 pi over 9. So when k is 1, I'm going to add 12 pi over 9 to 4 pi over 9. I get 16 pi over 9. That is still less than 2 pi, because 2 pi would be 18 pi over 9. So I have to count that one. If I let k be 2, obviously that's so close to 2 pi. If I put in k as 2, I would be over. So I just had the two answers there. Here I did the same thing. Multiply by 2/3. Here I get theta. Here I'm going to get 8 pi over 9. Again, all I'm doing is multiplying 2 over 3 plus 4 pi k over 3. So when k is 0, I got my one answer. My one answer would be 8 pi over 9. If I put in k as 1, I'd be again multiplying, or adding, I guess if I multiply by 3 over 3, I'd be adding 12 pi over 9. That's when k is 1. And if I take 8 pi over 9 plus 12 pi over 9, I get 20 pi over 9. That's too big. Remember, 18 pi over 9 is 2 pi. So I only have one answer down here. I had the two answers up here. So in total, I have 3 answers, which kind of corresponds to that 3 right there. Okay? All right. All right, number 4. Let's solve for sine of theta. So 2 sine theta equals -1. Sine of theta equals -1/2. What angle has a sine of -1/2? So sine is negative here and here. And that means the x value is radical 3 over 2. The y value is -1/2. So that's a reference angle of pi over 6. So over here with a reference angle of pi over 6, that would be 7 pi over 6. And here it would be 11 pi over 6. So all that one, the only thing with that one is you have to solve for sine. Alright, let's try number 5. Here's my angle. My angle has a cosine of -1. So where is the cosine equal to -1? That's over here at pi. It's the only place it happens. So my angle, 2 theta minus pi over 2, equals pi. Again, because I have a coefficient here, I have to go plus 2 pi k. So it could equal pi, it could equal 3 pi, 5 pi, any of those. And that's the only one I have, though, because the cosine is only equal to -1 in one spot. So we first have to solve for theta. We need to add pi over 2. So 1 pi plus 1/2 of pi would be 3 pi over 2. And then we have to divide everything by 2. Divide 3/2 by 2, I get 3/4 plus pi k, dividing all 3 by 2. Alright, so once I do that, I say, okay, when k is 0, I get 3 pi over 4. When k is 1, I'm going to take 3/4 plus 1. So 1 pi is 4/4 plus 3/4 would be 7/4. That's still under 2 pi, and those are my two answers. Again, if I put k is 2, 3/4 plus 2 pi is too much. Alright, and the last one on 6. Again, here's this angle I'm looking at. That angle has to have a cosine of 1/2. Well, that happens. Cosine is 1/2. It's positive over here and over here. If the cosine is 1/2, the sine is radical 3 over 2, so that's a reference angle of pi over 3. So what's inside here, my angle, has to be pi over 3. Again, do I have to worry about having multiple answers? No, because it's divided by 3, so when I get my answer, I'm going to be cutting it in half, so I don't have to worry about getting multiple answers. So it's pi over 3, or my angle could be over here, which would have a reference angle of pi over 3, which would be 5/3 pi. Alright, so how do I solve? Here I need to add pi over 4. So let me do that over here. When I add pi over 4, I'm really adding, I gotta get a common denominator, which means I would have theta over 3. This would be in twelfths. This would be 4/12. If I multiply this one by 3 over 3, this would be 3/12 pi. So if I have 4/12 plus 3/12, I get 7/12 pi, because I'm adding, remember? And so then I have to multiply by 3 over 1, multiply this by 3 over 1. I would get theta equals, here the 3 cancels with that to give me 4, 7 pi over 4. And that is in my range of answers, so okay. Here I'm going to add pi over 4. So I got to get my common denominator, which again means this is going to be, if I multiply by 4 over 4, 20 pi over 4. This one I multiply by 3 over 3. I get 3 pi over, or I said 20 pi over 12, sorry, 3 pi over 12. So when I add those together, I get 23 pi over 12. Multiply by 3 over 1. Get theta equals, here's 4, 23 pi over 4. 22 pi over 4. And that's way over 2 pi, so I cross that one off. So my only answer is the 7 pi over 4. Okay, so when you're doing these, really the only time you have to worry about that plus 2 pi k is when you get one that looks like this.